Hello again, this is Keith Davis at KLJ Instruments. Now that I have discussed the SQTR-2M synchronous interference and asynchronous interference mode of operation in previous videos, I am ready to demonstrate the wide area multilateration or WAM mode of operation. As the table shows, there are several significant differences between the WAM mode and the previous modes I have presented. The first difference is that the WAM mode allows for the programming of not just stationary, but also moving targets. Also, for Mode S targets, bit errors may be programmed into the data. Finally, other types of targets, such as ACRABs and UAT, may be in a scenario. To accommodate these expanded features, the GUI has 14 menus associated with the WAM mode of operation. I will describe these menus a bit later, but first I want to explain the method that is used to program moving targets. The flight path for each moving target is described by 2 to 6 waypoints. Each waypoint is programmed with a latitude, longitude, altitude, etc. and a time. As a scenario runs, the SQTR-2M updates the data in the squitters for each target so that each target moves in a straight line from one waypoint to the next. If there is time remaining in the scenario after a target reaches the last waypoint, each target continues moving along the same path. In addition to updating the squitter data, the SQTR-2M adjusts the relative timing of each squitter to produce realistic time difference of arrival between the signals at the 4 MLAT ports. To do this, the SQTR-2M must be programmed with the location of each ground station for the scenario. Now that we have touched on the concept of waypoints as a method of programming moving targets, let's take a look at the WAM menus. First, I will open the SQTR-2M GUI and select the WAM mode from the main menu. The WAM test setup menu is very similar to the previous test setup menus we have seen before. The difference is that previously we had a single target setup button, but now we have 3 buttons: 1090 target setup, ground station setup, UAT target setup. Since the 1090 targets and UAT targets operate at different frequencies, any given scenario can only contain one type of target. But regardless of the type of target that is being simulated, the ground stations must be programmed to get realistic TDOA timing. I will enter ground stations locations that roughly correspond to the simple map. I'll place the first ground station at a latitude of 38.889 degrees, longitude of negative 94.823 degrees, and an altitude of 1,200 feet. I will continue entering latitudes, longitudes, and altitudes for ground stations 2, 3, and 4 to place them corresponding to our map. If I wanted to increase the accuracy of the TDOA timing and the RF levels, I would edit the values for cable loss and cable length for each channel. But for my simple demonstration, I will leave these at the default 0 values. I will exit back to the test setup. In a moment, I will run my scenario and view the results using the radar cape receiver. But I want the radar cape to display the locations of the ground stations. So I will park a Mode S aircraft on the ground at the location of each ground station. To do this, I will select 1090 target setup. I will reserve target 0 for my moving target and begin with target 1 for MLAT 1. I will assign the flight ID to be MLAT 1, set the version to be DO260B, and the RF level to -50 dBm. Latitude, longitude, and altitude are the same as the MLAT 1 ground station. I will leave the target on the ground and enable the surface squitters. Now I will repeat this process for MLAT 2, MLAT 3, and MLAT 4. Now I must enable these 4 targets by selecting Enable Mode S Targets 0 through 99 and checking the boxes for targets 1 through 4. I will accept these changes, which takes me back to the Target Setup menu. In the previous 2 modes, the length of the scenario could be set by the number of squitters transmitted or by time. In the WHAM mode, the length of the scenario is only set by time. I will set my scenario length to 1 minute 30 seconds, then compile the scenario. After exiting back to the Test Setup menu, I want to save my GUI file and my scenario files. I will use the file name W for fixed targets for the GUI and the scenario files. Now let's run this scenario and view the ground station locations on the Radar Cape map. Yes, these locations look about the same as the drawing. Thank you for watching this video introduction to the WHAM mode of the SQTR-2M. In the next video, I will add a moving target to my scenario.